Hey guys, today I will draw graphs again. I think this is my last time explaining about graphs because graphs are real. So graphs are most important to master when it comes to Fourier series. Yabo. Sizodweba nje mhlambe 3 for ama-example ethu 4. I will not consider manje ukuthi sinama-constant ethu sinama-values, but sizo-assume sakhona ama-values. I will start with the graph of sine and cos, which is our most important graphs in our maths. I will start with the sine graph. Sine graph is look like this, and it passes 0. It passes 0. Sorry for that, but it's passing 0 here. Sine graph and turns back, and it's usually equal in turning point 1 and turns where it's -1. This is sine graph. Or it can be like this if you not consider this position. A sine graph can be either be like this. This is also a sine graph, but here my measurements are not good at all, but it's 1 here, and here is -1, here is -1 and 1. This sine graph y equal to sine, let's say x, and here is y again, sine x. These are same graph because they are same functions, because this is sine graph and this is a sine graph. You see, yeah, this both graph are sine graph, and when you see this graph, they rotated. This graph rotated backward. This graph rotated like this, back, rotated back, and this graph rotated back, but in the opposite direction. You see, that's why I'm saying this is the same graph. This graph is sine graph. Yeah, that's why I'm saying these both graphs are sine graph, because they are rotated with that curve. Yeah, with the curve. This move, when we rotate here, they rotate about the origin. This x origin. This is y. This is x. This is y. And when it comes to Fourier series, you must know that this function is odd. This function is odd because it's not symmetrical. If it is symmetrical, you will see a parabola graph. You will see a parabola graph. Say here is 0. Let's say our parabola graph is look like this. This is symmetrical graph, because what you see on this side, you see again on this side. That's why I'm saying this is symmetrical. This is symmetrical graph. This is symmetrical graph. This is an odd. Okay, that's odd, and this is rotated. This is nothing. This is rotated about origin. This rotates about origin, and this again is rotated about origin, because this is a sine graph. This again. My English is not good, but I'll try. This again rotated. Rotate, rotate like this, guys, like clockwise, but backward. But what direction? This is rotated clockwise. When you start here, it's rotated clockwise. But this one, when you start here, rotate anti-clockwise. You can master it like that, because it's the same thing of mastering. If the graph is rotated every time, once you see the graph is rotated, you must know that is odd function. You must know that is odd function, because that graph will be rotated, because or is rotated is odd function. If graph is symmetrical, when you double at the middle of it, you see the parts reveal on other side. That is money. That is symmetrical graph. You must know that is symmetrical graph, and the symmetrical graph is even. And here we can cause in the first of this lesson, I started with sine. I can draw the cos graph here, because cos graph is symmetrical. Don't mind this. We draw here the cos graph. Let's say the graph of cos. We must know the graph of cos is either up here, like then turns again and goes down, turns again. And when you cut in the middle of this part, it will reveal on other side, on this side. This part is equal to this side. This part is equal to this part. What does mean? This means this is an even function. Why I'm saying this is an even function? Because it's symmetrical. It's symmetrical. Once you see your function is symmetrical, you must know that your function is even. Once you see your function is rotated to the origin, you must know that your function is odd. So the things you must know is that. And when it comes to Fourier series, you must know with an odd function. Once you saw, or once you after drawing this function in the Fourier series, once you find that your function is like this in the Fourier series, you must know, and this graph is this graph of sine is odd function. This is odd function. You must know that a0 equal to 0. No, an equal to 0, because this a0 and an reveal the cos. Actually, I think it's for cos. It's for cos, whatever the variable is. This part when your graph is odd. When your graph is even, you must know bn equal to 0, because even functions are symmetrical and reveal the cos, where cos we have our a's, a0 equal to something, an equal to something. Then another thing you must know, and you must never forget about Fourier series, is cos n pi and cos 2n pi and sine n pi. This is equal to -1 to the power n every time. Because if you make your calculator to become radians, then and put any number here, it would become negative. And when you put and in the top, and you can make one, put one here is bunny, even. One is odd, 2 is even, 3 is odd, 4 is even. So the formula of odds and evens is 2n minus 1. This is a formula, of odd values. What I meaning? Want to put number 1 here. 2 times 1 is 2. Minus 1 is 1. Which if I put 1 here, that is odd. The formula, and if I put 2 here, 2 times 2 is 4. Minus 1 is 3. And I will put 3 here. That will be odd. The formula of even 2n. Any number if I put 1 here is 2. If I put 2 here is even. If I put 2 times 2 is 4. If I put 4 is even. This is a formula of even values. And you must know all your formulas of your for a series is given on the notes. You must check your notes.